Properties of sets. A union B equals to B union A. You may be thinking, hey, it's simple, what's to do with that? You all know that 2 plus 3 equals to 3 plus 2 equals to 5. Yes, that's correct. But you need to know what is commutative law. Okay, just remember commutative law. In your higher studies, you will come to you would come along these properties in other topics of mathematics as well, like in the binaries you will come to know, and in also in a discrete mathematics you will come to know about this. So if you understand this now, it will be more useful in later on. So A union B equals to B union A, it's commutative law. It's similar to 2 plus 3 equals to 3 plus 2, like that's a simple one. And then associative law, what does it say? That if A union B union of C, means first you calculate this, then you calculate this, then and in the next side you calculate A B union C, then you calculate the whole with A union, then it's the same thing. You can understand this it's like same the above example I gave you. 2 plus 3 plus 6 equals to 2 plus 3 plus 6. Will that be equal or not? Yes. 5 plus 6 11 equals to 2 plus 9 11. So it's equal. Yes, we understand that it's equal. And it's called associative law, that which one do you associate with the other. Like if you are given A union B union C union D union, for example, so if you know this associative law, okay, that if you do this first and then this, then also it will be the same answer. And if you take these three at once and then do the union with D, then also it will be same answer. And if you do this one, then also it will be same answer. So you know that, okay, whatever I take as like I associate any one of them with anyone, then also my answer will be same. For example, you are given to find A union B union C union D, and you are given A union D, okay, and you are given B union C. So okay, you will associate this way. Okay, that's fine, that's correct. Okay, that will work fine, right? But what about this A union union D? Will that also work? How will you identify it? So when you use some of the properties, then you get to know that yes, I can work this way also, that I will take A union D union B union C. That will also work the same way, because you know that okay, there is one commutative law which says A union B equals to B union A. Then there is one associative law which says A union B union C is equal to A union of B union C. So you know these properties, so whenever these tricky questions come along, you can solve them. I'll rub this. And then A union A is equals to A. Yeah, you will think, what is this? A union A is A. Yeah, definitely it will be not. So idempotent law. It's just a idempotent law. You know that union A is always A. And what your task will be, that you have to, I'll give one question. A is 1 2 3 4, then B is 6 2 3, and then C is 1 3. Okay, you have to take this as example, and you have to calculate this, and then this you have to compare it. Is it equal or not? You have to calculate this, you have to calculate this, you know this, and you have to compare this. Yes, it's working. Like they really satisfying the equations on left and right or not? That will be your question, and you will also learn this while practicing. You have to remember this commutative law, associative law, idempotent law. Now properties of intersection of sets. Earlier we studied properties of union of sets. Now intersection of sets. Some of them are similar, some are not similar. Let's see. A intersection B equals to B intersection Z. Yeah, commutative law. Yes. A intersection B equals to B intersection A. Yes, yes. That means common in both. Common in this will be common in this definitely. Okay, that's similar to the properties of union. And then this one, A intersection B intersection C equals to A intersection B intersection C. This one is also we have understood in associative law of union of sets. It's the same associative law in intersection of sets also, and idempotent law also it will be same, but the difference, one new law here is A intersection B union C. See, one is intersection, the other is union. Okay, in this case how do you understand this? This is distributive law, means I'll make you understand this in this way. If you are given, if you know algebra, you are given A B plus C. If it is given, here it's multiplication, here it is plus. So how do you solve them? A times B plus A times C. Okay, or if you want to understand this, 3 is there, 6 plus 2 is there, what will be the answer? 3, and if you sum them, it's 8, 3 8s are 24. And other way you can do is 3 times 6 plus 3 times 2. Now this what I have done is we have used distributive law, and then you calculate this 18 plus 6, this is also 24. So similarly in sets also, A intersection B A union C is equal to A intersection B union of A intersection C. This is distributive law. In this example I will try to solve this one, and rest you will have to solve. Okay, okay, I'll go with this one. I'll first calculate B union C. B union C is equals to, what does B union C mean? Union, you know that first take common part, then all the remaining of B and C both. So in B and C what are common? I see only 3 is common, so I will take 3. Then I am left with 6 comma 2. Then here I am left with 1. Okay, and now you have to do A intersection B union C. A intersection B union C will be, you have to do intersection of this and this, and you know intersection means common part. Okay, 1, yes, 1 is common, okay, take it. 2, yes, common, take it. Then 3, yes, it's common, 3, take it. And 4, no, it's not common. So in the left hand side we are left with this. In right hand side we have to first calculate A intersection B. Okay, A intersection B I'll calculate. We know A intersection means common in A and B both. 1 is not common, we will not take. 2 is common, yes, we will take it. 3 is common, yes, we will take it. And 4 not common. Okay, and then we will take this one, the bracket one we do solve first. Okay, always. A intersection C. Now intersection between A and C is 1 2 3 4, like 1 is common, 2 is not there, 3 is common, take it. Okay, now you have to do union of these two. See, A intersection B union of A intersection C. So you have to do union of this A intersection B and union of A intersection C. So union of this, first take common one. What is common? 3. Okay, I will take it 3. Now the left one is 2 and here is 1. Okay, see, 1 2 3 1 2 3, it's same, right? Don't see that 1 2 3 from left to right and then it's the same. We can write it this way also, doesn't matter. So see, we have proved this one, distributive law. Try to prove all of this. This may be seem very easy and not useful, but sometimes in the trick questions, if you are in a mostly you don't get trick questions in sets, but in other higher classes in discrete mathematics you will get this useful very much. Okay, thank you.